Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be about the development of a truncated pentagonal pyramid, and this development will be obtained by using the radial line development method. So here we are required to draw the sectional top view and the lateral development of a pentagonal pyramid of base 30 millimeter and height of axis equal to 60 millimeter, and this pyramid is lying with its base on the horizontal plane, and one of the edges of the base of the pentagonal pyramid is perpendicular to the vertical plane. So you see here we have a pentagonal pyramid and these are the 5 edges A, B, C, D, E, and one edge, that is AB, this is lying perpendicular to the vertical plane, right? And this pyramid is cut by an auxiliary inclined plane which is perpendicular to VP and inclined to HP at an angle of 30 degree. And where does it cut this particular pentagonal pyramid? It is cutting the pentagonal pyramid at a point on the axis 20 millimeter below the apex over there. So this is the apex point O. Here will be my point O1 of the axis. So this axis is going to be cut. This will be pierced by this cutting plane at a point which will be 20 millimeter below the apex or the vertex over there, and the angle of inclination of this cutting plane, this happens to be 30 degree with respect to the horizontal plane. Now we can observe that all the 5 slant edges of this pentagonal pyramid will be cut by this cutting plane. So thereby we are going to obtain 5 points of intersection for this particular pentagonal pyramid, and this top portion of the pentagonal pyramid which has been cut out, so this will be discarded out, and the remaining solid section view and the development we are required to draw over here, right? Now let us see the orientation of this pyramid that we are going to draw onto the top view, because here you see we are given the fact that one edge of the base happens to be perpendicular to the vertical plane, and since this pentagonal pyramid is resting on its base, that is the pentagonal base onto the horizontal plane, so in the top view we are going to obtain true shape of the pentagonal base over there. Now this pentagonal base will be drawn, that is the true shape will be drawn on the horizontal plane in the top view. So this will be drawn below the XY reference line. Now if we draw this pentagonal or base in this, you see, orientation, this will be incorrect. Why? Because if my XY line lies here, so none of the edges of the base, they will happen to be perpendicular to the vertical plane. So this is my correct orientation, that is if my XY line lies here, then this edge of the pentagonal pyramid base will be lying perpendicular to the vertical plane. So I have to draw the pentagon in this orientation, right? So let us start working out the projections of the pentagonal pyramid, which is an uncut pyramid to begin with. Then we will see how the cutting plane is going to cut this particular pyramid. So step number 1, so we have drawn the XY reference line. So having drawn the XY line, X reference line, now we have drawn the base of the pentagonal pyramid over here. Just see, this is the base of the pentagonal pyramid, and one edge of this base happens to be perpendicular to the XY reference line. Now the edge of the base happens to be 30 millimeter, and let us mark all these points of the base A, B, C, D and E, and edge AB happens to be perpendicular to the vertical plane. Now the next thing is we need to work out the axis for this pentagonal pyramid base. Now in order to obtain the axis, what we need to do, from every corner point I have to draw the perpendicular bisector of the opposite edge of the base. So from D I will be drawing a projector which will be bisecting the edge AB over here. From the corner E, again I will be drawing perpendicular bisector of the edge BC. From edge C, I will be drawing the perpendicular bisector of the edge AE. Similarly, from point D, I will be drawing perpendicular bisector of the edge AB over there. So this way, from all the points, from E, once again perpendicular bisector of BC will be drawn. So wherever these 5 perpendicular bisectors from the 5 corners they are drawn, so wherever they are going to meet, we obtain the access point over here. And many students, they make a mistake in the case of pentagon figures, that they will extend this line and then they will assume that this is going to be the pentagon axis. No, this is wrong. The axis of the pentagon will be lying slightly below this projector line, which is going to join the corner C with corner E. So slightly below that. So it's not that this is going to be the axis line. This is incorrect, right? So having obtained the axis of the pentagon pyramid, now we have to join all the slant. You see, these are the slant triangular faces over there. So this is first triangular face, this is second triangular face, third triangular face, fourth triangular face, and fifth triangular face. So why we have joined them? Because all the triangular faces, they will be visible to us from the top view. And why we have not darkened them? We have drawn them solid, but we haven't darkened them. The reason is because there is going to be cutting of these slant edges in the front view by the auxiliary inclined plane, and the remaining portion of the slant edges we are going to join thereafter. Now, having obtained the axis, now I am going to draw the axis line and the projectors from all these points of the base onto the vertical plane. So this is my axis line and these are my projectors from all the points of the base onto the vertical plane. So the projections of the base will be lying on the horizontal plane, that is on the XY reference line, since the pentagonal pyramid is resting on its base on the horizontal plane. Now B dash A dash, this is the point which is corresponding to the projector which is drawn through B and A. So this is the front view of the points B dash A dash. Similarly, you draw projector through C and E. So the front view projection C dash E dash we are going to get. You draw projector through point D on the base. So D dash point will be located on the XY line because the base of the pentagonal pyramid is lying on the horizontal plane. Now I know the axis height. The axis height is given to me as 60 millimeter. So having drawn this axis height, the top point of the apex, that is O dash, has been evaluated. So O dash location has been fixed. So once the position of O dash point is known, so I can join all the slant generators. So once again, the slant generators, they are joined with solid lines, but they have not been darkened because the cutting has to be done over here with the help of AIP. So one thing we need to remember, the projector corresponding to OA, that is the front view projector corresponding to OA, should be dotted. That is O dash A dash should be dotted. But these O dash A dash projections in the front view, they will be overlapped by the solid line projections corresponding to the projector OB. So therefore O dash B dash projections will be the solid line projections. So they are going to overshadow or overpower, or they are going to coincide with the dotted line or the hidden line projections corresponding to the projector O dash A dash. Similarly, over here, projector corresponding to OE in the front view should be dotted. That is O dash E dash should be dotted. But these dotted line projections corresponding to OE, that is O dash E dash, they will be overpowered by, they will be coincided with the solid line projections corresponding to the edge OC. So O dash C dash projectors, they will be dark, and O dash E dash projectors over here, they will be dotted. So the dotted line or the hidden line projections, they have been overpowered or by the solid line projections corresponding to the edge O dash C dash over here. So all the three projectors we have to draw with the help of solid line. So we haven't darkened them yet because again the cutting has to take place. Now let us work out the orientation and location of the cutting plane. So the cutting plane is located 20 millimeter below the apex. So the cutting plane passes through the axis at a point 20 millimeter below the axis point or below the apex or the vertex point. So once I draw this 20 millimeter, so this apex point, you see this point of the cutting plane on the axis has been identified. So this is my apex or the vertex. You move 20 millimeter down on the axis line, and this gives me the point of intersection of the cutting plane with the axis. Now the cutting plane is at an angle of 30 degree with respect to the horizontal plane. So here we have an auxiliary inclined plane which passes through all the 5 slant generator. You see, slant generator O dash, A dash, O dash, B dash have been cut by this plane over here, and the name of the points of intersection, they happen to be 1 dash and 2 dash. So 1 dash is the point of intersection of the cutting plane with the slant generator O dash, A dash, whereas 2 dash, it is the point of intersection of the cutting plane with the slant generator O dash, B dash over here. Then the next one, the point of intersection of the slant generators O dash, C dash and O dash, E dash with the cutting plane, they are 3 dash and 5 dash. So 3 dash point lies on O dash, C dash generator, and 5 dash point, it is the point of intersection of the cutting plane with the generator O dash, E dash. And finally the 5th point, that is point number 4 over here, it lies on the generator O dash, D dash. So O dash, D dash front view projection corresponding to the slant edge O4 has been cut by the AIP at the point 4 dash over here. So you see all the 5 points of intersection, they have been appropriately identified and located in the front view. Now we need to locate all these points in the top view. Now I have to locate the points 1 dash, 2 dash, which happen to lie on the slant generator O dash, A dash and O dash, B dash in the top view. So in order to locate these 2 points of intersection in the top view, what I need to do? So I will be drawing a vertical projector through the points 1 dash and 2 dash, and wherever this vertical projector, it is going to intersect with OA and the OB. You see, projections of the slant edges in the top view, I am going to get the location of the points of intersection 1 and 2 in the top view, right? So point 1 happens to lie on the slant edge OA, while point 2, it is the point of intersection of the cutting plane and it is lying on the slant generator O2. So similarly, through the points 3 dash and 5 dash, which are lying on the slant projectors O dash, C dash and O dash, E dash respectively. So from these 2 points of intersection, now once again one more vertical, you see, projector will be drawn, and wherever this vertical projector is going to intersect with OC, we are going to obtain the point 3 in the top view. Similarly, wherever this vertical, you see, projector through 5 dash, it is going to intersect with the slant generator OE, we are going to obtain the point E over there, right? So last point over here is point 4 dash. So point 4 dash, it is the point of intersection of the cutting plane with the slant generator O dash, D dash. So through 4 dash point of intersection, now another vertical, you see, projector line will be drawn, so that wherever it intersects with the slant generator OD, we obtain the point 4 in the top view. So here we go, we have been able to obtain points of intersection 1, 2, 3, 4 and 5 in the top view, and now we are going to join them. So these are the edges of the surface which has been obtained by the cutting of the pentagonal pyramid by the auxiliary inclined plane. So this is the top view of the section surface over there. Now this portion has been shaded because this portion was sectioned by the cutting plane, and we call this portion as section top view, and it represents the apparent view of the cut section in the top view. And having obtained the section top view, now we need to join the remainder of the slant edges. You see, the remainder of the slant edges we have joined in the front view to begin with, and then we are going to join all the remaining slant edges in the top view. So A1, B2, 3C, then D4 and E5. So all of these slant edges, they have been joined. Now we can see that this is a projection of the section solid which has been cut by the cutting plane. So the front view will look like this. So we have darkened this portion of the remaining solid. Similarly, the top view is going to look like this. Now the next thing is, now we need to work on the lateral development of the pentagonal pyramid. Now in order to develop the lateral surface of the pentagonal pyramid using radial line, you see, development method, two things will be required. The first thing is edge of the base. I have the appropriate information regarding true length of the edge of the base. So edge of the base happens to be 30 millimeter. Now there are 5 slant edges in this elevation view. Please check. There are 5 slant edges: O dash, A dash, O dash, B dash, then O dash, C dash, O dash, E dash, and finally you have O dash, D dash. Now I need to work out whether any one of these 5 slant edges, if I am able to see the true length of the slant edge in the front view or not. So please let me start with OA. So OA is inclined to XY. Similarly, O dash, A dash is inclined to XY. So this is no longer the true length. It is an oblique length. OB is inclined to XY line, and similarly O dash, B dash is inclined to XY line. Again, this is an oblique line. Similarly, OC, it is inclined to XY line, and similarly O dash, C dash, it is also inclined to XY line. So again, OC generator is an oblique line generator. Then OE, again it is inclined to XY, and similarly O dash, E dash also happens to be inclined to XY reference line. So again, this is not a true length representation either in the top view or in the front view. But now please refer to this particular generator. Generator, slant generator OD. Slant generator OD happens to be parallel to the XY reference line. It means that this slant generator OD, it is parallel to the vertical plane. So since slant generator OD happens to be parallel to the vertical plane, its projection on the vertical plane, that is its front view, O dash, D dash. So this will represent the true length of the slant generator. So since true length for all the slant generators will be the same, so here in this figure we have evaluated O dash, D dash will be my true length of the slant generator. Why? Because the top view or the plan projection corresponding to the edge OD happens to be parallel to XY or parallel to vertical plane. So the front view O dash, D dash will represent the true length. So this is true length. O dash, A dash, O dash, B dash, O dash, C dash, O dash, E dash, they are all apparent lengths. Now you see the points of intersection 1 dash, 2 dash, 3 dash, 5 dash, they have been obtained on the apparent lengths over there. So in the radial line development method, I cannot draw these arcs over there corresponding to the distances O dash, 1 dash, O dash, 2 dash, O dash, 3 dash, and O dash, 4 dash, because I need to find out the true lengths of these points of intersection, cutting points over there. So what I need to do, so as usual, from 3 dash and 5 dash, I will be drawing a horizontal locus line so that it intersects with the true length at the points 3, 1 dash and 5, 1 dash. So rather than using these two radial distances on the projection, on the development, I will be using the radius which will be equivalent to O dash, 3, 1 dash and O dash, 5, 1 dash. So these will represent the true lengths corresponding to the points of intersection 3 and 5, right? Similarly, from 1 dash and 2 dash, once again, I will be drawing a horizontal locus line so that it intersects with the true length at the points 1 dash and 2 dash. So I will be discarding this radius. This will not be taken into account. So instead, wherever points of intersection 1 and 2 have to be located, so there the distances of O dash and 1 dash and O dash 2 dash will be used over there. So now you see, for the 5 points of intersection, the true lengths have been located on this particular true length, right? So let us start working on the development of the pentagonal pyramid. So this is my point O, you see, which is corresponding to the apex. So the capital O point will be located here. The arc length, this arc length will be equal to true length of the slant generator, which is equal to O dash D dash. So this is the true length of the slant generator. So this true length of the slant generator will give me the radius of this arc. So having drawn the radius of this arc, next thing, I know the edge length, that is equal to 30 millimeter. So from point A, I have started my development by cutting the solid from this point A. So my starting point will be point A, and once I move 360 degree, my end point will also be a point A over here. So I am starting from point A. So first edge, first arc I will be marking over here, second arc, third arc, fourth arc and fifth arc. So 5 arcs I am going to mark, and I am starting from point A. After the first arc, point B will be there. After the second arc, point C will be there. After the third arc, point D will be there, and after the fourth arc, point E will be there. And many students, they start from A and they end up at point E. No, you have to reach back to the point A, otherwise one sector or one arc you are going to miss over here. So having marked all these 5 arcs over there, then these 2 points, they need to be joined with the help of straight line. That is, all the base edges of the pyramids, they will be joined with the help of straight lines over there. So we draw the straight lines and then we join all the slant edges over there. So slant edge first, second, slant edge third, slant edge fourth, slant edge fifth, and again the slant edge number 1, right? So we start with slant edge 1, slant edge 2, slant edge 3, that is OC, slant edge 4 is OD, slant edge 5 is OE, and again back to slant edge 1, that is OA. Now this is the development of the non-truncated pentagonal pyramid. Had this pyramid not been cut by any cutting plane, but since we have obtained that this pyramid is being cut by an AIP which is inclined at an angle of 30 degree to HP, now the POIs, they have been located in the front view. So those POIs need to be translated over here so that the actual development of the truncated solid can be obtained. Now you see, where my first generator, that is OA, has been cut, my first generator OA has been cut at a point 1 dash, but this point 1 dash, that is POI 1 dash, point of intersection 1 dash, lies on the apparent length. So this is not acceptable. So what I have done, I have drawn a horizontal locus line so that it intersects with the true length. And what is the true length? True length is O dash D dash. So wherever it intersects with O dash D dash, I obtain the true length of the point 1 dash, and this name of this point will be 1 dash. So this radius, you see, now I am going to pick radius from O dash to 1 dash. So this radius I will be measuring with the help of compass and mark 1 arc over here and 1 arc over here. Okay, so one point will be located here. Similarly, one point will also be located here. Now the second, you see, my second generator is OB. So where is OB? OB lies here. In the front view, OB lies here. So since 1 dash and 2 dash, they are both coinciding with each other, but these are lying on the apparent length. So now I have transferred both of these points onto true length. So the distance of O dash 1 dash and the distance of O dash 2 dash will be the same. So this distance of O11 is equal to distance of O21. So I have marked another point over here, that is the point of intersection on the developed surface. Now my third generator is this one's third slant edge OC. So where OC has been cut by the cutting plane, so O dash C dash has been cut by the cutting plane at the point 3 dash, but 3 dash is again lying on the apparent length. So I cannot take this distance O dash 3 dash. So what I have done, I have drawn a horizontal line, transferred this point 3 dash onto the true length. So my new point becomes 3 1 dash, which is a true length corresponding to the POI 3 dash. So I will be measuring this distance O dash 3 1 dash and mark it over here. So O dash 3 1 dash has been measured. Please check, it is this distance. This distance has been measured and marked over here. And similarly OD, now you see this is true length, true length, true length. So suffix 1 are there with respect to first point, second point and third point. But please see fourth number point. So 4 dash point lies by virtue of cutting off the edge O dash D dash by the AIP. But here there is no 4 1 dash. Why? Because it is already lying itself on the true length over there. So since it was itself lying on the true length O dash D dash, so it need not be transferred to the true length distance over there. So this point's name will be only 4 dash. So if it is only 4 dash, what I am going to do, I'll be measuring this distance now in original. So O dash 4 dash distance in original will be measured and it will be transferred over here. So this distance will be called O4. So no one subscript is there, you see, right? So no suffix is there after the point 4 because it is already lying on the true length. Then OE, this has been cut by the cutting plane, that is O dash E dash has been cut by the cutting plane at the point 5 dash. But this is the apparent length of the radius. So I have again transferred it onto the true length. Now this is the new radius, which will be the radius of true length over there, right? So this true length radius corresponding to 5 1 point we have located here. And finally O1 we had drawn. So the same O1 will be transferred over here. So all the points of intersection have been transferred, but please see point 4 is the only point which was already lying on the true length. So no suffix 1 was added, whereas all other points, that is 1, 2, 3 and 5, they were lying on the apparent length. So the true lengths have been worked out for all of these 4 points of intersection by transferring them onto the true length, right? So having obtained these 5, you see POIs onto the developed surface. Now we are going to join the corresponding points. So all these points, they have been joined. So these are the slant edges 1 1 A1. You see these slant edges, they represent the true length and they are much bigger than true lengths which were visible in the front view or in the top view, right? So this is the development of a truncated pentagonal pyramid which has been cut by a cutting plane which is an AIP inclined at an angle of 30 degree, and it passes through a point on the axis 20 millimeter below the apex or the vertex over there. Okay, so with this, using the principles of projections of solids, sectioning of solids and the radial line development method, so we have been able to work out the front view of the section solid, top view of the section solid, as well as the development for the truncated pentagonal pyramid. So this is all that we wanted to discuss regarding this development. So thank you very much. Thanks a lot.